So on the left you have Circle CI pipeline. The final step is that you publish an image into your Docker repository. And then on the right side you have a GitHub repository. And there's a commit there that's committed by Flux. So this isn't a person doing it, this is like the Flux user doing it. And it updated the image that was published by Circle CI. So you can set up rules where like any image published on master automatically goes into your repo. So we have this enabled for staging environments where we just release right away as soon as the Circle CI pipeline goes through. But in production, you can also use it manually, so you don't have to deploy to prod on every commit. And I'll go back to Michal, who's going to talk about some data science stuff.
So some of our favorite tools that make our job easier are listed on this slide. What's especially nice is that Heroku prides itself by being a simple tool, and our Kubernetes setup kind of does that as well, because we heavily leverage customize. So we have all these ready-made templates for cron jobs or deployments or services ready to go, where you sort of like extend it or inherit it in an OOO-ish manner, and you get all the benefits of injecting secrets and all the other stuff that Mark has mentioned. But in addition to that, it allows us to be more explicit if we want to go with some custom setups, like scale the resource usage or deploy a certain amount of API versions of sorts. And it also allows us to specify the node affinities and anti-affinities, where we can leverage some GPU instances if we were to have them, and so on. We also really like Flux because we build the images, we review the PRs in our repos, and when it gets to master, all the stuff gets built, gets tagged, and automatically propagates across all our jobs without us doing anything. But then if some incident were to happen, we can switch back to manual release pretty quickly and just change the tag to the previous one or roll back. And then another big benefit for us is that all the infrastructure is plug and play. People from our company spend considerable amount of time making it easier for the developers and data scientists to use this platform. So there's a common library that we can leverage to push tags or basically any metrics to Datadog. We can throw all our logs into CloudWatch, and we love the UX experience and the simple design of Vault and Console, where we store all our secrets and configs, and they automatically appear in all of our containers and code without any hassle. And Mark's gonna continue.
We're getting to the end, I swear. So just wanted to point out some of the gotchas that we that we kind of like hit as we were deploying all this stuff. So monitoring your cluster is super important. If you don't do that, you really should start doing that. So you can better analyze the CPU and memory profile of your jobs and applications, but also so you can better bin pack your applications on nodes, right? So ideally you want your nodes to be 100% utilized. And the way to do that is if you look at your apps and look at the profiles. Most like monitoring tools need to run as daemon sets, so what that means is you have one per node. So there's two things you need to watch out for. So one of them is it can get costly. So we use Datadog, and they charge per host. So we prefer fewer bigger instances than many small ones. And then the other thing is resource usage. So we used to use a tool called FluentD for forwarding logs to CloudWatch, and that's what the graph there is. Basically, it used to consume 700 megabytes of memory just to read logs from a file and send them to CloudWatch. And we switched it for another tool called FluentBit, which is from the same people actually. It's just the first one is in Ruby and the second one is in C. So that's how you save memory, basically. And that one only needs like 70 megabytes of memory, right? So when you have when you have a cluster that has like 4 or 8 gigabytes of memory, and your tool that reads log files and sends them to one place requires almost like 1 gig, it's just way too much, and it's a deal breaker. So yeah, do send logs to a central place, because the pods disappear after a time. So you can get the logs from the cluster, but eventually the pods that run your containers disappear. So yeah, like what we're looking at next, there's a few things. So the first one we've kind of already done, and it allows us to run web applications in the cluster. So by default in the cluster, you can call out other services running in the same cluster, but it's kind of harder for services running outside of the cluster calling a service in the cluster. So the reason for this is the way the DNS works in Kubernetes. So you need to handle this with ingress controllers, which set up DNS and load balancers for you to get into the cluster. We would also like to tackle pod and node auto-scaling. So if you have a job or an application that has a spiky profile, you know, like when people go to bed, the usage goes up almost to 0, and during the day it's pretty high. You know, it's not in Kubernetes by default, so it's something you need to add in manually. Release management in terms of when you create the branch and you start working on your application. Wouldn't it be nice if there was something that auto-deployed that branch to a Kubernetes cluster, and you could hit that URL. It would give you a URL, and you could hit that URL, and it would have your version of the application, and you would get this for every branch. Like that would be super nice for us, because we could use it for quality assurance, that kind of thing. Finally, Michal will talk about this a bit more, but like we want to do a better support for data pipelines. So currently we can run cron jobs, which are nice, but if you have dependencies between your cron jobs, you need to work that in the schedules, right? So you run one at like 12, and then you run the next one at like 1, so that the data that the first one produces is ready. So, you know, there are tools that can help you with that. And then finally, like, why not use Kubernetes for your development environment as well? Currently we use Docker Compose, but maybe running it in Kubernetes is also an option. Yeah, so Michal, you want to talk about the...
Yeah, so we've collected some of the projects that might be of interest for you. If you're dealing with a lot of complex data workflows, there's a pretty neat tool called Argo, which runs on your Kubernetes cluster, and then you can link the individual container commands without the hassle of scheduling cron jobs at 12, then at 1, and so on. And it also allows you to parameterize some of these commands. So if you have like a giant matrix of stuff you want to test out, you can throw it at it, and it generates all those jobs automatically. Then there are some specific tools that allow you to mix and match Kubernetes and Python, especially Prefect, Dagster, and Dusk. So you can sort of write your pipelines or your DSL inside the code, and then the scheduling and backfilling and spinning up the actual pods and jobs is handled by these other tools. So you get all the benefits early on from your code. And then if you're doing a lot of machine learning and deep learning experiments and workloads, you can leverage Kubeflow, which is built on top of Argo, where you can also define pipelines for training your models. You can spin up Jupyter notebooks with various resources or GPUs and so on. And it can also store artifacts of your experiments that you can explore later on and see which model, for example, performed the best. And we were also looking at Dusk on Kubernetes. So if you're familiar with Python and Pandas, Dask provides similar API to data frames, but you can offload a lot of the work to the cluster itself, so you can massively parallelize your workflows and handle larger amount of data coming in. And so this concludes our talk. Thank you very much for paying attention. And we have some last words from Daniel.
I didn't prepare for this one. This talk was much better with a mug of beer. So next time I learned that we have a presentation, I have to order everyone a mug of beer. And I'm sure it's going to be much better as a result. But it's me trying to make a joke when the reality is we are carefully hiring. We're hiring amazing star employees who can carefully choose the balance between technology and reasonable use of technology. When you have technology without reason, it kind of misses the point sometimes. The combination of data science operations, the backend operations, SRE, developers, to result in efficient company operations, that's kind of the awesome thing that you want to get. So if you think you can run fast and carry the burden and want to have a lot of responsibility and choice and freedom to innovate, stop by and look at the site. We have a about page. We're hiring here in Rubyslava. So again, data scientists maybe, developers with data science background very likely, developers of any kind absolutely. Sign up.
You just said data science.
And then, of course, if you have any questions, feel free to stop by and ask us. Also in Slovak. Thank you.
Ďakujeme, dáme si 10 minút pauzu a potom druhú prezentáciu. Medzičasom si môžete objednať pivo, teraz spúšťame budget od Kiwi.com. Ďakujem.